Right? Uh, Instruction set means basically when we give instruction, so there is computer has to perform action on instruction. So instruction have two parts: opcode and operand. In a computer system, instruction set are a set of operations, okay, which are decoded in sequence. Do you know we have done decoded, fetch, decode, execute cycle? Okay, this so that is the instruction which has to be decoded.
Okay.
Each operation will instruct the ALU and CU, which are part of the CPU. An operation is made up of an opcode and operand. Opcode mean uh, the opcode informs CPU what operation need to be done. As I told you, plus, minus, divide. Okay. Okay. Addition. Opcode can have a addition, subtraction, kind of that. Now, what is operand? The operand is the data which need to be acted on, or it can refer to a register in the memory. Operand can be address of memory or data itself. Okay. Got the idea? Okay. You got it?
Wait a minute. So
Done? You understand?
yes. Yes.
Okay. Now see further instruction or further detail. So here is definition again. Instruction are sequence operation decoded and executed by the system. Okay. Now each operation instructs the arithmetic and logic unit and control unit within the system. So operation means it gives instruction to ALU and C.
Mhm.
Okay. Then it says component of operation. An operation consists of an opcode and operand as we have discussed. Okay. Opcode specify the operation to be performed, and operand provide data or location for the operand. As I told you, your operand can be address and data on which operation has to be performed. So operand means data item which has to be operation. So it says limited number of opcode due to the need for computer to understand operation. There is a limit. There is a limited set of opcode. This limited set of is known as instruction set. Got the idea?
Right. Okay.
Okay. Let's go through this one, then let me know if you don't understand. Yeah, have you read?
Wait. Okay. Wait. Okay.
1 minute.
Well,
1 minute.
okay.
Okay, so you understand this material? Any confusions? Yes, are you there?
Sorry.
So you understand?
Yes.
Any confusion?
No.
Okay. Now see this one. Caution on instruction set and programming code. So what about low level? Do you know low level language?
Low level language is the language which the computer can understand.
Directly.
Yes.
Kind of binary language. Normally we work on high level language. That has to be converted to binary form. Now it says instruction sets are low level language instruction for the CPU. Okay. So programming code require interpreter or compiler to convert into the instruction set understood by the compiler. So whatever high level language we use, we need to have two translators. That is, one is interpreter, one is compiler. Do you have any idea regarding compiler and interpreter?
No.
Basically, these are translators like Python, Java. They could not run their program directly. they need to run their program with the help of interpreter or compiler. Got the idea?
Wait a minute.
These are basically two translators, which works with high level language like Python, Java, Visual Basic, C language, C++.
Hmm. Teacher, what is a compiler?
Compiler,
Yes.
there are two translators. One is interpreter, second is compiler. Both are translators. Compiler convert whole program at once. You might have typed 100 lines, 200 lines. Compiler translate the whole program at once. But interpreter convert line by line. Interpreter convert line by line. These are translators which are used to translate your high level program into machine code. Because we do programming in our own language. Okay. So computer could not understand your program code. Got the idea? Like if you do.
So compilers and interpreters are used to transfer language to the language which the computer can understand.
Yeah, you are right. That is the point. Like, have you done Python? Any language? Have you done Python?
I have used Python in grade 8,
Okay.
I think.
So whatever you are writing a program in Python, it need to be converted to machine code like Python. Okay. And these are done by these two translators. Either it performed by interpreter or by compiler. Okay. And they have given example of instruction set. Okay. Now see here. Name 3 buses used in the von Neumann architecture. You remember?
Yes.
Which one?
That data bus, address bus, and control bus.
Control. Good. You are right.
Can you go to the previous page?
This one?
Yes.
Done?
Okay.
Now you have to describe the function of each named bus. Can you briefly define? What does by address bus, what does by data bus, and what is the role of control bus?
Address bus carries the signal that contains the address of the instruction from MAR to the MDR.
Okay. And data bus?
Databus is used to is used to carry the data itself from the MDR
Okay.
to the CIR.
To the CI. Good. And control bus.
Control bus is used to send signals to the operators to execute
Okay.
from the control unit.
Okay. Now see here detail. Address bus carries address throughout the computer. It is unidirectional. You should also tell this one. Direction. Data bus bidirectional bus allowing data to be sent throughout the computer. Control bus carries signal from the control unit to all other computer components. It is bidirectional.
Teacher, what does unidirectional mean? And
No. Unidirectional. Single path. It means it can only read. Unidirectional means it can only read, not write. And bidirectional means bus can read and write at a time. Bus can read and write.
read
But-
and write.
Yeah, read and write. Both operation can be done by this bus. Processor can use this bus to read and write operation. And address bus is only carry data. That is why it doesn't require another operation. There are two operations: read and write. There are two operations: read. Okay, read and write. Read means you have to pick data. Write means you have to store data. Okay, got it?
Okay.
Okay, done.
Yes.
1 second. Okay, now see this one. Describe how bus width and clock speed can affect computer performance. So do you have idea?
Buswidth expands the capacity of the buses, which allows more instructions, more signals to go through it.
Okay.
And clock speed can increase the speed of the computer performance, but not improve. And it can also cause the unsynchronization of the computer system performance.
Okay. Now see this one. wider address and data bus would increase computer performance. Okay. Like as I told you, it can be 4 byte. To increase to it 8 byte. 8 byte is better than 4 byte. So wider data address bus and data bus would increase computer performance. Wider control bus would have little, if any, effect on performance. But control bus width is not matter. Matter is address bus and data bus. Okay. So higher clock speed would increase processor speed. If increased by yourself, it will create an overclocking. Would have serious consequences. However, such as unsynchronized operation or overheating. Unsynchronized means other part of computer will be behind the operation. Okay. At the same time, they could not perform. Got it?
Okay.
Now see this one. You have to complete. Batch execute cycle. Do you remember? The registers, the role of register.
Yes. Should I tell you?
You should tell.
Okay. The CPU
Batches. Okay, good.
batches the data and instructions required for an application and temporarily stores them in the PC.
Okay. No, it's CIR. Yeah.
Yeah.
It's here until they can be processed. Until they can process. This is PC.
Okay.
Why? Next keyword is next. For PC.
Okay.
Now see next one.
The address is copied to the address copied to the MAR using the address
Okay.
bus.
Okay, good.
The contents at this address are stored in the MDR.
Okay.
Each instruction is done and each instructions is then decoded and finally executed by
Okay.
sending out
Control signal.
signals.
No, control signal.
By sending out control signals using the control bus.
Okay.
Any calculations carried out are done using the any calculations are carried out are done using the
ALU. ALU. ALU.
Huh? Yes.
ALU. Arithmetic logic. You remember CPU has two parts, CU and ALU. Remember?
Yes.
CU gives the direction and ALU perform the operation. Calculation. During any calculation, data is separately held in a special purpose known as which register? Here, what will be the answer?
During any calculations, data is temporarily registered known as the accumulator.
Accumulator. Good. Very good. 8 others. Most of your options are correct. But correct. Okay, good. See this. Okay.
Okay.
Now see this one. So what will be here?
Wait, the process is wish, what should, I didn't understand what should we do?
It says show the content of MAR and MDR. If we read the content of memory location, 41000010. This is the address. This is the MAR.
Mm-hmm.
So, and what will be the MDR? This should be MDR.
Mm. Okay,
Got that?
yes.
Here you can see 1010 0111. Got it?
Yes.
Now see this one.
Right. Mm. Oy. Mm. MDR and the MAR is the address and MDR is the contact.
Yeah. Here you have. So you want to write this is the data MDR. So where it is written into memory 1000. This one.
Mhm.
Okay. And this is the data. Got it?
Okay.
Okay, now explain this one. Yeah. Any idea about CIR?
Monomerase register, it is
Full name of register. And then function of
wait, central
no current
no,
current
current
instruct.
instruction register.
Yeah. And function of register.
Passing of this register. Uh, it holds the address and it holds the instruction temporarily before it's being decoded.
During decode. See this one. To store the instruction being decoded and executed. Okay, CIR hold those instructions which are being process, okay, on which processor is working. Got the idea?
Yes.
Store the current instruction being decoded and executed. MAR,
MR,
MAR. What is MAR full name?
memory address register.
Okay. Now function of
Fine.
register.
Its function is it stores the address of the instruction before it.
No,
That's
not instruction. Memory location. Instruction of memory location. Got it? See here.
it holds
Store address of the memory. Address of the memory location can only be read or write. Read from or written. Okay.
okay. Wait.
What to read?
Okay.
Now MDR.
Its full name is memory data register.
Okay.
The function of it is it hosts the data itself before it is
You have
being
to use memory. Okay. Kind of that. See here. How to give answer? First, you have to its full name, then it's MDR. Store data. It has just been read from memory, read from memory, or data and memory or data is about to be written to memory. You have to use the word read or written, right? Okay, regarding memory. Got it?
right. Okay.
Now PC,
PC
full name is
name
program counter. Program,
program counter.
and what is the function?
The function is its function is it has the address of the instruction
Next,
next
next instruction. Yeah.
the next instruction which is about to be executed and decoded.
See here. Okay, done. You understood?
Yes.
Now see here. Explain the meaning of following term with reference to the system clock. So what is the purpose of system clock?
Is this wait. Is it steps it is steps used by the CPU to how to say to apply the operations to apply the steps in sequence.
Okay. Here you can see clock speed are measured in gigahertz, which is the vibrational frequency of a clock, which send out pulses along the control bus to synchronize operation. So every part of computer must know.
But say it's closed cycle.
Yeah, clock cycle. So clock cycle basically the clock speed are measured in gigahertz. Okay, you understand?
Wait. Okay.
Okay. Now see cache. Do you know cache?
It said is a register that can that's the access of the access to the other components and CPU is faster than RAM.
Yeah, RAM, RAM. RAM means RAM. Call it RAM. It is slower than RAM. Okay. Cache is nearest to CPU processor. That is why, because it is faster than RAM, but storage capacity is lower than RAM. Okay.
Isn't
Yeah,
isn't cache faster than RAM?
yeah, cache is faster than RAM. Cache is more faster than RAM. A temporary memory location using static RAM. We also call it SRAM to hold data or instructions that are frequently used by the processor. A larger cache memory increases processor performance. Normally, it comes in MBs, maybe 8 MB, maybe 16 MB. Okay. Your cache can be 8 MB or 16 MB, but RAM comes in GBs, 8 GB. RAM in terms of storage, 8 GB. Okay. Got the point?
Right.
But cache is faster than RAM. Done?
Yes. Yes.
Now it says discuss how changes to the clock speed and to the number of core can affect the performance of the CPU. Include any advantages and disadvantages due to these changes in your system.
Teacher, can you explain what core is?
Processor. Core means a processor. It has three components: CPU, ALU, and register.
Close mechanic. It's
So can you do? Should I discuss?
wait.
I'm coming in 1 minute. Okay. I'm coming.
Okay.
Okay, should I discuss?
Yes,
Should I discuss?
yes,
See here. It says increasing clock speed can improve performance. However, it can lead to overclocking, which can cause operation to be unsynchronized, which can cause serious overheating of the CPU. The use of more core can improve processor performance, for example, dual core and quad core. However, doubling the number of core doesn't necessarily double the performance because the CPU need to communicate with each other, reducing the overall performance. You got it?
wait. Wait a minute. Okay,
Okay.
yes,
So you understand?
yes,
So enough for today.
okay.
So, see you in next class.
Okay, and that
Yeah,
is.
Allah Hafiz.